RP. In the earlier video, we were solving problems based on continuity. Now let us see how to explore such functions using GeoGebra. I'm, I'm going to type y equal to sine of 1 divided by x. Okay, now what do you observe? See, we want to find what is limit x tends to 0 sine 1 by x. Let us look at limit x tends to 0 sine of 1 by x. So this is the graph, okay? So look at the behavior of the graph near x equal to 0. So when we talk about limit extending to 0, x approaches 0 through values left of 0 to the right of 0. So what happens is it keeps on oscillating between -1 to +1. So limit extends to 0 sine 1 by x does not exist. So this is something which is very difficult to visualize, right? So, but if you use a software like GeoGebra, the visualization helps us to understand these functions much better. So if you look at the function sine of 1 by x and we want to study its behavior near x equal to 0, we find that it is keeping on oscillating between -1 to +1. Keeps on oscillating. That's why it's called an oscillating function. Now, because it keeps on oscillating and does not attain a finite particular value, we say that sine 1 by x as x tends to 0 does not exist. Is it nice? Are you able to follow? Now let's go on to the next one. Let's open a new file. Okay, now let us look at x square into x square into sine of we are looking at x square into sine of 1 by x. See, I want to explore the following problem. Let f of x be equal to x square into sine of 1 by x when x not equal to 0, be equal to 0 when x equal to 0. Now what do you observe? See this sine, look at the behavior near 0. As x approaches 0, x square into sine 1 by x is becoming closer and closer and closer to 0. So as x approaches 0 or x tends to 0, x square into sine 1 by x also tends to 0. What is f of 0? F of 0 is 0. So the value of the function is also 0. Therefore, f is continuous at x equal to 0. It's very nice when you observe here how it becomes closer and closer to 0. That is what I want you to see, and that is the beauty of the graph of x square into sine 1 by x. Is it clear? Okay, in my earlier video, we also discussed how the behavior of sum of two modulus functions look like. So even before that, how does a graph of a modulus function look? Y equal to absolute value of so this is y equal to mod x. I also told you that by the intuitive, you should have an intuitive understanding of the meaning of continuous functions. If you can draw the graph of a function without lifting your hand, then it represents a continuous function. By definition of mod x, we know that mod x when x is greater than or equal to 0 equal to minus x when x is less than 0. So what is this portion of the graph? This is y equal to x. What is this portion of the graph? This is y equal to minus x. So I can draw this graph without lifting my hand, right? So we find that the function is a continuous function. Modulus of x is continuous. Even if you take any value, a small neighborhood around 0, what will be the value of mod x? 0. So mod 0 is 0. Therefore, mod x is a continuous function. Is it clear? Okay. Next, what we will do, we will see sum of two modulus functions. So I am going to type absolute value of x as x minus 2 come here, then we'll have add a plus sign, and then we will have absolute value of x minus 3. X minus 3. So now what do you observe? So this is a graph that we explored in my earlier video. We wanted to check the continuity of this graph at x equal to 2 and x equal to 3. So how did we do that? Let me redefine the function for you. We saw that f of x modulus of x minus 2 plus modulus of x minus 3, modulus of x minus 2 equal to x minus 2 when x is greater than or equal to 2 is equal to 2 minus x when x is less than 2. Modulus of x minus 3 is x minus 3 when x is greater than or equal to 3 equal to 3 minus x when x is less than 3. When x is less than 3. So when we simplified this function, modulus of x minus 2 plus modulus of x minus 3, okay, and we called it as f of x, we can redefine it as first x is less than 2. What is the function when x is less than 2? This is 2 minus x. This will be 3 minus x. So what will I get? So 2 minus x plus 3 minus x will give me 5 minus 2x. So you can see the graph is now cutting on the left hand side at 5. So 5 minus 2x. Now when you have 2 less than or equal to x less than or equal to 3, what will be the graph? Modulus of x minus 2 will be what? When x is greater than 2. So when x is greater than 2, you have x minus 2. But it is less than 3. So plus 3 minus x. So you will get 1, right? So this will be 1 when 2 is less than or equal to x, less than or equal to 3. What will happen when you have x greater than or equal to 3? When x is greater than 3, what will be f of x? X minus 2, x minus 2 plus, since it is greater than 3, it will be x minus 3. So you will get 2x minus 5. So this is this side, it is 5 minus 2x. This side of the graph, this straight line is 2x minus 5. And this, what is this portion of the graph? Y equal to 1. So this is y equal to 5 minus 2x. This is y equal to 2x minus 5. This is, as you can see, y equal to 1. So how does the graph look like? The graph look like a bucket, or you can call it as a trough. We normally call such a graph as trough. So this is y equal to 1 between 2 to 3. So it matches with our definition. To the left of 2, what is the function? 5 minus 2x. So when I put x equal to 0, y is 5, you can see. When I put x is 0, y is 5. To the right of 3, how does the function behave? To the right of 3, y equal to 2x minus 5. Because when x is greater than 3, f of x is x minus 2 plus x minus 3, which is 2x minus 5. So this is 5 minus 2x. This is y equal to 1. This is 2x minus 5. And I can draw this graph without lifting my hand. So by the intuitive definition of continuity also, the function is continuous. Okay. Even otherwise, we have also discussed the continuity. What will happen to limit x tends to 2 minus? When x is 2 minus, what is the value of the limit? Limit x tending to 2 minus of f of x will be what? I have to substitute 2 here. So 5 minus 4, which is 1. What is limit x tending to 2 plus of f of x? That is 1. So when you have x equal to 2, here also the limit is 1, very close to 2. So if you take a small neighborhood, that is again close to 1. So the value of the limit is 1. And the value of the function at x equal to 2 is also 1. What happens at x equal to 3? Okay. So limit x equal to 3 minus. When I say 3 minus, what is the function? I will have f of x equal to 1. What will be limit x tending to 3 plus of f of x? What is the function? We have 2, when x is greater than 3, 2x minus 5. So what should I put? In the place of x, I should put 2 into 3 minus 5, which is also 1. So you can see in both at 2 and 3, the left hand limit is equal to right hand limit and is also equal to the value of the function at the indicated point. Algebraically, we have discussed this in great detail in the previous video. So this is the geometrical representation of the sum of two, how the graph of sum of two modulus function looks like. And we know it is continuous because we can draw the graph without lifting your hand. So GeoGebra is a wonderful tool to use to visualize, to understand mathematical concepts and to develop deeper insights into such concepts. So we will use more and more of GeoGebra to connect algebra with geometry. So until next time, it's goodbye and from Max with RP. Do not forget to listen to the entire video. Please go through the entire video. Do not forget to subscribe, share and like. Thank you.